So now let's talk about the last parts of covalent bonds that we're going to be discussing, which is polarity, solubility, and the properties of covalent bonds. So when we're talking about polarity of a covalent bond, that's formed when there's a large difference in electronegativity. So items that are closer together on the periodic table are often more nonpolar than things that are apart. And all this means is that there's an unequal sharing of electrons, meaning there's going to be one atom that's going to have the electron more, so it's going to get more slightly negative, and the other one's going to get more slightly positive because it's not having the electron as much. These form those partial negative and partial positive charges, and they're called dipoles, simply because di meaning two poles, so it's two poles, a positive and a negative. And if you think about the Earth, it's also called dipolar because we have a positive south pole and a negative north pole, and I might have gotten those two mixed up, but we have two charged poles that are positive and negative. Okay, so let's talk about what nonpolar and polar means. So nonpolar means similar electronegativities and the charges in a Vesper shape are going to be balanced. And polar means dissimilar electronegativities and charges are not balanced in a Vesper shape. You're kind of looking at it in just a visual format. Look how much smaller hydrogen is to fluorine. It means it's going to be polar. Hydrogen to oxygen is going to be polar. And you can see how the shape's going to kind of recognize that. It's going to be more of a bent shape versus nonpolar. It's going to be very even, similar sizes. So nonpolar are going to be similar sized. Polar is similar sized. So let's talk about solubility, especially for polar molecules or covalent molecules. It's important that like dissolves like. So polar and ionic molecules are going to be soluble in polar substances, but nonpolar substances are only soluble in nonpolar substances. This is why oil and water don't mix, because oil is nonpolar and water is polar. And this very fact is why we are not big piles of goo on the floor, because your cell membranes are nonpolar. Despite your blood being polar, it doesn't dissolve your cells due to the polarity of the membranes. Okay, let's talk about the differences in attractive forces. So covalent is just the basic force between atoms and molecules, which is strong between the molecules in an atom, but between different molecules, which is the intermolecular forces or van der Waals forces, are weak. So let's talk about those intermolecular forces. Your dispersion force is going to be your weakest, and that's between two nonpolar compounds. Your dipole force is going to be stronger than your dispersion force, and that's the intermolecular force between two polar compounds. And your hydrogen bond is going to be your strongest, and that's the specific bond between a hydrogen and a fluorine, a hydrogen and an oxygen, or a hydrogen and a nitrogen. So finally, let's talk about covalent properties. So covalent molecules consist of uncharged or neutral molecules. They most normally consist of liquids and gases. They are soft, solid, and waxy with a low melting point. So if you think about how you make real caramel, which is sugar that just melted in a pot, you make caramel out of sugar because sugar is a covalent compound and it melts at a low melting point. And caramel, not that Werther stuff that has the caramel flavoring that's hard, but the true caramel is soft and waxy, and that's why it's pliable around the apples. Remember, they're not a conductor in all states, especially solids. And remember, solubility in water or solubility in general depends on its polarity. Remember, like dissolves likes. Thank you for learning about covalent bonds.